one of the major changes that Avaya has done since the acquisition of Nortel enterprise position, which that division also brought in the networking division. And so what we've done is really created a stack of capabilities from clients to applications to infrastructure to network, all with a management capability. So taking the best of our applications, Aura, Contact Center, our UC platforms, network, and management, and devices like Flare Communicator, and really building a stack of capabilities in which each one of the stack layers can communicate together. So you can take and have an end-to-end solution for unified communications in which the network infrastructure understands what device is connected, what individuals connected, what application is running, and be able to bring enhanced features across all of the stack. And so we've been working on that for the last year, and we've been, from a network side, enabling technologies that allows clients and applications to run better on an Avaya network. So a more seamless or more application-aware network.
And when we talk about, from your perspective, what is software-defined networking, and how does that roll into what you're already doing with shortest path bridging, the identity engines piece, and the network segmentation, whether we call it VLAN or otherwise?
Well, the way, when you hear about software-defined networks, it's a big umbrella of a lot of technologies. And there's a lot of features and capabilities, and companies branding them as software-defined networks. I look at this as really two components. For when you think about software-defined networks, you have the network side, and when you think about the network side, is how do you virtualize the network so you can get multi-tenancy? How do you scale virtualized networks to map to the applications you're trying to run or the users that you're trying to bring onto the network? And we use shortest path bridging to build that fabric, so you can have a very scalable network architecture where you can fluidly build network connectivity for an application and scale that to tens of thousands of virtualized networks. So that the other piece is the control side, and that is having controls where you can control the network assets through commands, or be able to communicate to applications that are running and need resources in the network. And so when we look at this at the sense of, okay, just some simple things. Let's say you're running a video session, and you're running, in our case, Scopia, which is our high definition video. And you want to connect individuals. It's a very important video session, so you want to connect the individuals, and you want to have high priority. So you want to create a session. You want to put individuals into their own virtualized network, right? So you have data separation. Then you want to make sure that you have the highest performance, so you can do high definition from all of the participants. And then you want to monitor that session while it's happening to ensure that you have the right quality of service, so you can do high definition. So when it comes to software-defined networks, if you have the fabric enabled for the network, so you can create a network for this one particular video session. So that's one. Two is, while the session's going on, having the network look at the path to ensure that every hop within the source to destination has the highest priority queuing, so the video session has good quality. Now, if there's an error, a real-time error in the video session, whether it's misconfiguration of the queuing of the data packets, or it's jitter or a latency problem, you want to be able to detect it and take corrective action on it. So we have a couple things that we've done. One is we put quality monitoring into our switches, so you can have heartbeats checking the path between all of the sessions of the video conference that's going on, and look at the quality of service, jitter, and latency. And if you see a problem, be able to identify where that problem's at.
Sure.
Right? So we can identify where the problem's at now. Second step is, well, can you route around the problem in the network? And then third is, if you can't, signal the application and let the application know that, hey, you're doing high definition video, we see a problem in one particular switch, the jitter is high or the latency is long,
Sure.
Go to standard definition.
Right.
That is a complete component of SDN. So you have the network side where you created the infrastructure, the virtualized network, and then you have the network and the application communicating together on the quality of the session. And so what we've seen is there hasn't been a lot of work to move to a virtualized infrastructure in the networking space until recently. And what we're seeing is a lot of customers that are embracing it, because it really has changed the way that they think about their networking architecture. Where in the past, customers had thought about the network in terms of, I have to build discrete physical networks to get data separation. Now, what I can do is build one network, physical network, and really now start to carve it up into n number of virtualized networks. And that's really starting to take off. Because more and more companies have come to the realization that when you think about the architecture, you need to be thinking about the applications and the people that you want in specific networks. As an example, if you're in an airport is the IT organization of the airport is a service provider.
Sure.
And who do they service? They service the lounges. They service retail in the kiosks. They service, to a certain extent, TSA. To a certain extent, the check-in counters. And you look at them, they're all individual users that all need to be separated from a data point of view. Your lounges, you want them to go to the internet. That's all the sole purpose, right? You want the airline desks, they all need to get to their headquarters to get their reservations. You have the retail, they have their own demands, right? They have their point of sales. Then you have the TSA, you have surveillance. Cameras are everywhere, right? Sure. And they all have unique characteristics. And so what Virtualized Fabric brings to the market is for an airport to come in and build a network and then put virtualized networks for all of their clients. And that's what shortest path bridging does. It gives you separation, it gives you the security, it gives you the scale that you need to add more clients or more users or more cameras. You know, on the camera side, surveillance cameras are taking off. And you have to be able to scale.
Sure.
So you have to put an architecture in place that can scale. And that's what Fabrics will give you. That's what shortest path bridging will give you. It will give you that ability to scale. It supports multicast natively, so you don't have to use PIM to continue to multicast. Everybody's moving more to multicast. It has to scale. Current protocols today don't. When you build a fabric and use shortest path bridging, it scales.
Yeah.
So you're now, when you're saying, what I didn't expect is, I thought that this would really be just a data center architecture, right? SDNs, virtualization, fix the data center. The interesting thing is the enterprise space is taking off relatively quickly as well. I would say that the biggest challenge for us as a company, or for me in the data networking business, isn't the technology, right? It's not developing it. We've got the technology. We have the technology. The challenge is getting out and changing the dialogue with customers on what they're trying to do from a business point of view, and being able to map technologies to their business challenges. Going out and talking to customers about speeds and feeds really doesn't connect anymore, right? Speeds and feeds, whether you have 48 ports of 1 gig or 48 ports of 10 gig, doesn't matter anymore. It's a leapfrog game. All of the vendors will all have the same capabilities. Timing may be a little bit off. The challenge is talking to customers and how do you solve some of the problems. I just gave you the example of surveillance. A lot of customers don't realize the problems that they're having with scalability of surveillance until you get into that dialogue. Change the dialogue. How people want to move from a CapEx model, meaning buying all their physical equipment and deploying it, to an OpEx, which may have a cloud component. Simple question to ask is, are you interested in utilizing a cloud model for your video? Changing that dialogue. Now, when you have that conversation and a customer says, yes, I think that's an area that I'd like to augment my data center and my IT, but what does that mean to me? Then you can map in, well, there's some technologies that you should put in place, right, for your cloud services. The other thing is in the data center, are you seeing the traffic trends of your data center moving east to west, which means top of rack? You're seeing more and more of your computation requesting information across multiple racks, as opposed to one request comes in, they call it north and south. It comes in from the south, goes in north, gets the answer, goes back out. Well, if you're seeing more and more of your traffic in your data center moving east and west, what are some of your challenges? How do you want to map that? Do you want to move it faster? Do you want to lower the latencies? And so that's where I spend a lot of my time, is kind of that awareness of things are moving so fast in the networking space, and they're changing so quickly. Let me just ask you a couple questions to see if you're seeing these problems, because there are solutions behind it. And so let me frame the problem, and if that is a problem, here are some of the solutions that we can give you.